should help. They include velocity. I'm not seeing velocity equations.
Person on ground. What are the forces acting on the person?
Gravity.
The gravity. Well, the force of gravity. I swear I wrote that. And the normal force. Wow.
Alright. So, if you are jumping up into the air, well actually, if you're just standing there, if you've got
In this case, friction is not applying to air.
say it again?
No air resistance.
No air resistance.
Yeah, it does say there's no air resistance.
Alright, so right now you're just sort of standing there.
Sorry. Mm-hmm.
If you are just standing there, which is bigger?
If I'm just standing there, which force has the larger magnitude?
Yeah.
Is the same?
Yes.
Yes,
Question
there
mark.
was no question mark.
So if I did a plot of the normal force versus time, it would basically look like that, where the normal force is equal to the weight.
Mm-hmm.
If I jump up into the air,
Okay.
which way am I accelerating?
Oh.
And therefore, which one's bigger?
Which force?
Yes.
Force is
Which
bigger?
force has a larger magnitude?
Normal, because that's going up.
Yeah, the acceleration is up, therefore that has to be the bigger force.
Oh, yeah, okay.
Once I'm in the air, which one has a greater magnitude?
Gravity.
Gravity.
Force of gravity in this case.
Or the force of gravity.
And why?
There's
Because
no
you're
normal
going
force.
down. Well, once you reach your
That's right.
Once I'm in the air, what's true?
acceleration is negative.
More than just that.
There's no normal force.
Yeah.
Because you're not in contact with it.
That's gone, therefore the net force is downwards, therefore the acceleration is down. All right, so if I'm jumping up into the air, so if I'm starting from standing or crouching position, some sort of stable, static equilibrium position, I go from here to, well, I have to have a normal force greater than my weight to accelerate upwards.
Yeah.
And then, at some point, I have no normal force acting on me.
Mm-hmm.
So when I'm landing,
Uh-huh.
I touch the ground,
Yeah.
so my normal force goes from 0 to something.
This is motion.
And am I speeding up or slowing down shortly after I touch the ground?
Slowing down.
I would hope so.
Yeah.
If you jump up in the air and then land and are speeding up when you land, you're in trouble. So
Can I ask
if
a
you're
question?
so if you're going down
Okay.
and you're slowing down,
Mm-hmm.
what's the direction of acceleration? Yeah, so
Um,
which one would be bigger as you're landing?
Normal. I mean, force of gravity. Yeah, force of gravity because.
Force of
Normal
gravity
force is
because
increasing, but the force of gravity is still higher, but the normal force is increasing.
Okay,
Yeah.
so let's drop back for a second. When you're landing, you're
Okay.
moving downwards,
Mm-hmm.
and at some point, very quickly, you're gonna start to slow down. If you are going downwards and slowing down, what's the direction of acceleration?
down.
We have a contradiction there.
No. Whoa. I mean, it's not.
Oh, disagree with
If
that.
gravity is working on it, then anything times a negative is going to be negative. So
Acceleration is positive.
Yeah, that's what I'm saying,
Acceleration is
down.
positive.
But we haven't defined a
acceleration.
positive or negative.
Okay.
Positive,
well,
positive
it's
is
up
up.
Okay,
Positive.
positive's up.
Yeah, okay, that's what was confusing me.
Okay, so positive is up.
Okay.
So if you are slowing down, velocity and acceleration are opposite signs.
Okay.
So if you are slowing down, as you are landing, you're moving downwards.
Mm-hmm.
acceleration would have to be upwards.
Yes.
Therefore, which one is bigger?
Gravity.
It's gravity.
If the gravitational force is larger than the normal force, that
Right.
means the net force is downwards, which means your acceleration is downwards.
But then I lied, it's the normal.
Yeah, sorry, you were just kidding, I didn't understand the joke.
Take a joke, yeah, take a joke.
Sorry, cousin Robert.
Huh?
So, we have this, so the net force is, normal force is gonna be the greater one,
Okay.
other than a very initial period when it goes from 0 to above your weight. That doesn't how long you're in the air. But the normal force will be bigger.
Okay, to be fair, I didn't do
Now, at some point, you're gonna stabilize.
that. Yeah,
You eventually get to 0.
yes.
So, gravity wants you to go down, and normal force wants you to not
So
phase through whatever you're in
Yes.
contact with.
Yes.
So then,
we're saying
so then if you're stopping, then normal force has to be bigger.
If you're falling and stopping, yes, normal force has to be bigger.
And that's the answer? That's it?
Well,
it's a global gravity.
that's the essence of the sketching when I didn't finish it, but that's question 2.
Yeah, this is the question 2 is what we're on.
Yeah.
2A.
4, 5 concept. Now, in all of this, you want to make up positive, what's the equation of motion?
The equation of motion?
Yes. We've done the force diagram, we established the direction of acceleration. We have set up our coordinate system, up is positive, nothing to decompose. Next step, equations of motion. Or in this case, a singular equation of motion. What is the equation of motion?
Y minus W is equal to mass times acceleration.
So you faded.
Y minus W equals mass times acceleration?
Thank you.
That's what she said, that's
Yeah.
not what I said.
No, I gathered it. Eva, you can speak that loudly, I'm sure.
Or maybe not.
So if you were standing on a scale, which of those forces is the scale measuring?
The normal force?
Like you mean it?
The normal force?
Yes. So in that other question, the question was asking about what is the normal force, the first part is the normal force, or what scale reading?
Yeah, it's the scale reading.
Yeah.
So this is what the textbook said, but.
And so this is the math equation you're working with if you want to go that route. Or, so if acceleration is positive, or if acceleration is upwards, which we said was positive, that should give you some hint about the normal force. If acceleration is downwards or negative, then it, well, in essence, this starts dropping. Or just think about the last time you were on an elevator, when you were going up, when it first starts, there's that initial feeling like you're being forced upwards.
Yeah.
If you were on a scale, the scale would read higher than your weight.
Oh.
As you're coming down, you get a little bit light just at the, initially, and that's, if you were on a scale, the scale would go below your weight.
So that's what you're saying, like if the accelerations are the same, then technically your normal force would end up being the same for all of these, but it depends on the velocity that it gives you, whether or not.
It has nothing to do with the velocity.
Okay, so why are we giving velocity then?
velocity? Is that to
Just to see
Screw
who
with
falls
you?
for that.
Okay, but okay, so then you're gonna have a lot, like you're gonna have a couple of these that have the same normal force.
Yes.
Because they have this, so how am I supposed to rank them?
Yeah, because it
You
says
can put
rate
it,
the
all right, you could do a ranking where, let's say you got A, B, C, and D,
Okay.
and A and D are the same and the largest. You
So-
do A equals D greater than, let's say D greater than C.
Oh, that's what you want us to do?
Or some people have done ADBC without an equal sign, in which case I take off for that. Or you could put parentheses around that to indicate that they're together.
So if I have, for example, I got two with a force of 700 and then the last, like another one with negative 700. That's just the direction of the normal force. Like it would even that.
Ask that again?
So whenever I did that equation, I got two that had 700 because their accelerations are the same, and then another one with a normal force of negative 700.
The normal force should not be negative 700. It would be 0 at. Did you remember to add the weight?
Yeah. Probably.
How'd you get negative 700?
I guess that doesn't make sense because their mass times acceleration would have been the same. So then.
In the case where it's in free fall, the acceleration is 9.8 meters per second squared downwards, assuming it's on Earth. If it's on Jupiter, it's not free fall. Down, if we're saying up is positive, this would be negative mass times acceleration, times an acceleration equal to the acceleration of gravity, plus the weight, so you should have had a normal force of 0 in that case.
In the case of free fall.
Yeah, the 9.8 meters per second squared down,
Yeah,
that, if that's on Earth, that's free fall.
right.
The cable has been cut, there is no friction. If the safety mechanisms are not in place, he's dead
I'll just redo it.
or injured.
Yeah, see, that's what I got. And then this one's also that. It's either this one or this one.
The mass for each person is the same, right?
Yes.
Okay.
Can we stop with these trick questions? I stay up like 2 hours thinking that mass can change.
Is this one is the same? Because
I
acceleration
hope you
is
break
0,
yourself,
so
but yeah,
700
the only way mass can change is you can eat a whole lot or go on a
And then
diet,
this one is the same too.
burst
Yeah.
into flames.
I think, yeah, this is the one that I got confused on. This one I got negative 700 for.
Oh, okay. Dr.
Did you
Jones,
want-
I'm confused too. And that would actually make sense why you're confused on that. I don't think I would have gotten that one. It's negative 9.8, right?
That's what I put, yeah, and I got negative 700.
But you're forgetting to put plus 700, which, oh, yeah. What does this mean? It's saying that, so if I use that equation for the last one, which like, the acceleration is negative 9.8.
Okay.
And then, so mass, for mass, the mass of each person is 71.43, right? So when I do 71.43 times negative 9.8, I'm getting negative 700. And so when I'm adding 700, because that's the weight, you would think you'd get 0, but that's not what I'm getting. My calculator is getting negative 1.4 e negative 8, which is like 0.000000 something 1.
I assume there's a rounding issue in there somewhere.
But I'm not rounding, I'm taking the exact number they're giving me.
So you did, how'd you get the mass?
I did weight equals mass times acceleration and then divided acceleration.
So you took 700 divided by 9.8,
Yeah.
and then you multiplied times 9.8
Mm-hmm.
and got a different number.
Wait. I did 700 divided by 9.8 and then times it by negative 9.8 and got negative 700. Makes sense because it's a negative.
Okay, so you got negative 700 for this,
Mm-hmm.
plus 700 for that.
Yeah.
So the normal force is 0.
Yeah, but like why isn't my calculator saying 0?
Because it's a TI.
So you just think it's not my fault?
I,
Okay, so.
so you got negative 700, and then you added 700 and did not get 0?
Yeah, that's
Yeah,
what I'm saying.
That's what
Yeah,
I'm being so for real. You can check. Like I'm not joking.
Is it time to get a new one?
Possibly.
Look, 71.428571 because that's what that is. And so I times it by negative 9.8, got negative 700, added 700. That.
And so you got, with the rounding thing, because this goes out to 3, 4, 6, this goes out to 8 decimal places. So it's basically saying that that 3 there is questionable.
B, so I would do A equals B.
There was a computer issue. Is it a Windows thing? There was an operating system thing where they had rounding issues like that built into it, which no one would notice except for people in finance and computer nerds. There was also various plots in the 70s and 80s of movies where people
Did you
would
know?
siphon those fractions off and basically embezzle money that way.
Did you know that on YouTube, if you right click on a video, it'll show you stats for nerds?
Oh, yeah, I have.
I love that.
All right, any other questions?
Where is everybody?
Yesterday
Possibly not on the bus.
class started, 3 people. I had 3 people in a class of 12.
It could be depending on where they live because of the hurricane, because some roads got really damaged.
That was far away though, no? I mean, I don't think.
I know someone in this class lives in Greensboro, like I heard.
Oh, really?
Yeah, like some kids do not live in like Winston.
It's okay over there.
So, okay, High Point's good.
I saw a
I would
sign
like
that
to
I
do
believe.
Asheville.
So I get
Pardon?
really
I saw a
confident.
sign that said I believe west.
That we post.
Over near Asheville, I believe.
Yeah, apparently Asheville is cut off from the world, pretty
Hmm.
much.
I think that was true before the hurricane too.
Yeah, you're kind of right, but apparently Biltmore Village